In case you're wondering what those shapes and colors were, they're actually modeled off of the silicon die that Intel produces billions and billions of every year. And the music was the sound of innovation. So you can keep that in your mind, and of course the video might have gone on for hours, but I had to cut it short. I want to thank John, Phil, and InnoVentures for giving me the opportunity to share with you a little bit about Intel's view of the road to the connected car. I've been with Intel for just a little over 10 years, and I've always had a focus on automotive. In fact, it's right here in Greenville that I spent a fair amount of time working with the BMW ITRC as Intel and BMW formed a collaborative research engagement and continues to do so right to this day. That led to the formation of the Automotive Solutions Division of Intel. So while we've been in the automotive business in one way or another for 30 years, now we have a full division with hundreds of employees focused on not only setting a plan for the company around automotive, but building products. You don't see those products necessarily on the road yet. We're still in the midst of releasing the specific products, but the vision is very clear, and it lines up very nicely with the rest of Intel's strategy. I think it's useful to note that the connected car is a very popular term, and it's not a destination. It's a road. It's a path that we've got to eventually reach towards as innovation appears more and more in automotive and high-tech combined. But before we talk about that too much, I want to take you back to a car that you might not even see on the road today. Some of you might remember that shiny leather seating of a car from the 70s. We selected this photo because there's an era, this represents an era when the first computer in the car appeared in the market. Now, we're not talking about a trip computer. We're not talking about an infotainment system that gives you the latest music videos. We're talking about a computer that sat in the engine compartment, and it helped to manage the operation of the engine and provide very useful diagnostic information about what was going on inside the car. Now, the mechanics, the service people, they were excited. They could see that now the customer could roll his car into the garage, they could plug it in, they could find out exactly what's wrong and fix it. But it led to some disappointment fairly quickly because they realized that sometimes the computer became part of the breakdown. It added its own set of challenges to the technology innovation. Well, over time, the engineers, the manufacturers, the suppliers, they figured out how to make these ECUs, embedded control units, really computers that include hardware, software, operating systems, sensors. They figured out how to make them so they pretty much never failed. Today's car, you don't see that many ECU failures. In fact, that process has been so successful that we now have hundreds of ECUs in every car. Some advanced cars have maybe 200 separate computers operating the vehicle. The customer, the driver, never even sees them. This is a little bit of a challenge for innovation. And at Intel, we think it needs to change. Now, while we're introducing computers that the customer sees through the infotainment interface, the standardization of hardware, software, reusable silicon, it's got to be there. It's the only way that innovation can really progress forward. There's a lot of software that has to be developed to create the connected car. We're starting with infotainment, but that's just the beginning. As we look into the future, we're going to see use cases that are going to be much more demanding than any ECU can provide. Today's purpose-built automobiles have silicon, software, and technology just enough to meet the current needs of selling the vehicle. Generally, they don't have any headroom to add applications, to enhance the experience, And that's what customers are looking for today, tomorrow, obviously well into the future. For example, some of the use cases that people are starting to realize are possible and maybe expected is that you're running late for an appointment. Your car knows this because it's interconnected through the cloud to all of your daily affairs that are, of course, kept electronically. And you're in danger of hitting some rush hour traffic, so it redirects you to another path to get you to your destination on time. Or maybe your car recognizes that there's a friend nearby, and the car calls the friend to see if you want to meet up, based on some profiles and preferences that you may have set up. The display on the car is an unobtrusive, digitally generated interface that gives you information about upcoming signage like stop signs or traffic lights or vehicles that are coming out of a blind spot. These technologies are all being developed today, but they're being developed in individual columns or clusters within the vehicle. And while they will appear on a scene, at first they're always very expensive to implement. And they're generally not available to the common, most mainstream vehicles on the marketplace. So we really believe that if we can successfully move the industry or influence the industry to a combined high-tech and automotive mode, that we can bring the standardization but still allow differentiation for all of the players in the ecosystem. I have experience with the Geneva Alliance. The Geneva Alliance, I'll mention once or twice today, is an organization that promotes the development of software. Now, Intel is very involved in this alliance. We do a ton of software development in the Linux open source environments. And as Geneva has been forming, we moved outside of the traditional open source developer environment into the automotive software ecosystem. An amazing discovery for me how large, how sophisticated automotive software development is. Some of you in the audience may be from that environment. But to date, there's been very little crossover between the software developers that are working in the automotive space and the software developers that are working outside of the automotive space. They don't talk to each other very much. So we've been starting to break those walls down. That's just one of the many things that need to happen in order for this massive amount of software to be created that will yield the connected car. Let's look at the flip side of the situation here. Pun. You know, really the connected car is a vehicle for massive growth in the industry. We need to look at it as something much more than taking your car and connecting your phone to it and then somehow connecting to the internet to read your mail or to send a text or somehow stream your music. That's already being done. The connected car is one where it's all harmonized in one central environment. The car is truly becoming, if it's not already there, a multifunctional device. Now this car looks more like a mouse. And I thought about that because it sure represents the ultimate in integration between a computer and the car. Because we know what a mouse does. It allows us to direct where we're going. But there are some unique challenges that automotive software innovation presents itself. For example, we have to deal with making and breaking connections while the vehicle is moving at speed. Now, we did some of that test work with BMW in Spartanburg in the test track, high-speed test track, and we validated that certain changes needed to be made to the standards to allow fast enough handoff when moving at high speed. And some of those standards evolutions are trickling into the telecom industry, not necessarily the automotive industry. So we see how the relationships are interwoven. You also have to be able to manage not only a partnership or connection with devices that are brought into the car. Many times people now have 2, 3, even 4 different devices that communicate wirelessly. And then you have 2 or 3 passengers, each, 4 or 5, each with their own collection of devices. This is a complex matrix of connectivity that needs to be managed differently in the car than perhaps in a home Wi-Fi network. but with a lot of shared issues that we can work out together. And then, very importantly, in the vehicle, you have to have an absolute appreciation and focus on ensuring privacy, security, reliability, and for sure, safety. But there is an opportunity within this. It's the opportunity to build out a rich graphical environment that the consumer or the driver would really appreciate. Using the car as a more intelligent device than any smartphone or tablet could ever accommodate because of its size, power, the ability to store computational capability, and ultimately improved driver safety. There's a lot of talk about improved driver safety, and everyone's interested in this. In fact, we hear a lot of talk about the autonomous car. The autonomous driving vehicle is a huge buzzword ever since, maybe it started before that, but significantly affected by the availability or the news reports about the Google self-driving car, which, by the way, you may have known in some of the news reports that there is an Intel computer inside that car. There's about 12 of them on the road. The technology behind that is certainly at an infancy, no question about it. It's going to take a while to develop this model of having a fully autonomous car. But meanwhile, the learnings from developing it are applying quite well to semi-autonomous or safety systems that utilize the driver as part of its sensing mechanism. But I want to focus a little bit for a minute on what one of those sensors is. The human eye, in a sixth of a second, can receive a full high-definition image. It takes that image and it incorporates it into 128 million rods and cones, assembles it into a set of connections that utilize 40% of the brain's nervous system, activates 50% of 100 billion neurons, makes a decision in 1/1000th of a second, activates a dozen muscles, and deals with a critical safety factor. The human eye is probably the most, I'm sure it is the most advanced, sophisticated, responsive sensor that we hope to be able to create for the car in the future. But of course, the brain is infinitely capable of solving many, many problems. So you could say that the human driver plus a well-engineered car become the ultimate driving experience. This is what it's all about, user experiences. And it includes safety. Unless the driver is staring at a 3.5-inch touchscreen. And I use the word staring because I'm sure everybody in the room looks at their phone from time to time when they're driving and they don't want to be considered one of the criminals. But its reality is that we can't resist the tendency and the urge to bring in all this information. This is a problem that has to be solved. Some people feel that autonomous driving vehicles will solve the problem. In it, you can take the driver out of the equation, let the car drive itself. It could be a wonderful thing. We know that it happened in George Jetson's car. That movie was, the TV show was positioned for the year 2072. So I'm sure by 2072 we'll have all these features and we'll have many, many incremental features in the way. But really for this audience, I think that everything around distracted driving or user interface or having the phone and the smartphones and the data centers be able to communicate without human intervention is an innovation opportunity. So Intel is committed to this. We're very interested in working with you on ideas that you have, and we'd like to help and work together to try to break through some of these challenges. Automotive is just as much a part of Intel's DNA as our PCs, our servers, tablets, and smartphones. I couldn't have made that statement to you a few years ago. Because of the innovation opportunities that we've discovered working with the auto industry and working with many up-and-coming software suppliers, we have formed an automotive solutions division that is as I mentioned before, a key element of Intel's overall strategy. So when we look at the computing environment, the experiential computing environment as we refer to it, we look at automobiles as a very big part of that. After all, 14 hours or 18 hours a week are spent in the car. And that's why people tend to grab their smart devices and grab onto that data, because they're spending so much time in the car that's otherwise useless to them, other than getting somewhere. Now, in terms of where Intel's at in innovation, in technology advancement, we are generally years ahead of the silicon industry overall. Not only are we a large company, which we know that has its good and bad characteristics, because it takes a while to make it shift, but in terms of technology, our systems, our manufacturing capabilities are really on par with the automotive manufacturing. One thing about automotive manufacturing is it requires a lot of capital, lots of large, expensive factories, lots of, well, technology has to be invested in all those spaces. Well, Intel does a tremendous amount of research, development to innovate new processes and new methods of making silicon parts less expensive and more powerful. We're on the bleeding edge, no question about it. 14 nanometer, if you know anything about silicon, is a pipe dream for most manufacturers. We're already in that space. 450 millimeter wafer sizes. Very few manufacturers even exist that can make the lithographic technologies to make these parts. So we're always used to being on this bleeding edge. And we have some experience with it when it comes to manufacturing. We're very experienced with what's needed to be successful in building product and at a profit. So we're not here to say the supply chain for automotive needs to give away everything they have. We understand how precious it is to keep profitability, differentiation in every aspect of the car manufacturing environment, right to the selling floor. And we've done that before, and we're interested in sharing it. Just give you a couple of data points on the kind of collaboration that we're involved in, and we invite you and others that are going to hear these messages over time to collaborate with Intel. First of all, the market is quite large. IVI, or in-vehicle infotainment systems, combined with telematics, represents an $8.7 billion market by 2018. That's a big enough number for Paul Lotolini, Intel's CEO, to say, let's invest. Now notice the timeline though, 2018, we're not going to get the payout right away. We're here for the long haul. We understand those issues. Intel's capital expenditure, I've referred to it before, $12.5 billion a year, roughly, take it or minus. Who could bet $6 billion on a new fab? If any of you go to Phoenix in the near future, you can get out of the plane, you can see cranes in the distance that are building the fab for Intel's newest manufacturing facility. The parking lot for the construction workers is as large as any major metropolitan shopping mall, and it's a temporary parking lot. $6–8 billion of investment, long-term planning. So we have to get the gear rolling, and then we have to keep it rolling. We make investments. Intel Capital is one of the largest venture capital organizations in the world. We've invested over time $10.7 billion in small companies. And of course, they always align to Intel's objectives. So some of you here have a big enough idea that you may be able to reach out to Intel for an investment. Now, I'm not the representative for that, so please don't ask me for the money, but we have a very capable organization that manages that whole process. Founding member of the Geneva Alliance. Combined with BMW, Intel, Wind River, and Magneti Marelli, we formed the foundation of the Geneva Alliance. It was the first open source implementation of an infotainment system. Infotainment is the way to break into the model. So we're investing heavily into this alliance, as well as all the activities that surround it, such as those created by the Linux Foundation. Linux Foundation recently formed another complementary organization around Linux for automotive, the automotive grade Linux work group. So combining these two groups, and hopefully more in the future, is the way that we see large amounts of software being developed in a collaborative fashion. So why should I invent a very basic rudimentary feature of the software and not share it with you when it has no value to me? That's the power of collaboration. I share it with you, you improve it, you give it back. Now, some people are nervous about that because they think they're giving away their intellectual property. They're nervous about licenses. How do these things get managed? Who owns the IP? Well, guess what? Nobody owns the IP, really. When you're talking about open source, you don't have to worry about being sued. But you do have to pay attention to the proper rules of licensing. And Intel is one of the most conservative organizations around when it comes to legal and IP protection because we have such a large patent portfolio. We use open source software, we believe in it, we support it, we promote it, and we think that everybody should be able to participate in that model. And the automotive industry is just getting acquainted with the idea, and it's because of Geneva Alliance that we really made that happen. Intel's overall R&D budget is in the tens of billions of dollars a year. We spend the money up front to get the results. Much of that, of course, is focused on silicon research and development, but a bigger and bigger portion of it is focused on automotive. We have a significant portion, since we formed the Automotive Solutions Division, now we have dozens of people in research, dozens of people in Intel labs that are working collaboratively with companies that you've seen announcements. If you looked at Intel's public announcements page, you'll see we've signed on some collaboration agreements with Toyota, with Nissan, and of course the work that we do ongoing with BMW. That's all part of that expenditure. Another selling point of having the investment in automotive is that it is clearly one of the three fastest growing areas for connected devices. So you know how fast phones are growing, you know how fast tablets are growing, autos are right behind it. And the neat thing about autos is that there's so much fragmentation in the industry right now that there's a lot of opportunity for people to be successful. There's such a big change that has to take place. It's like being in the phone industry 10, 15 years ago. The early adopters really did well. So I mentioned the Intel Capital Connected Car Fund. We set aside $100 million. This fund has a 6-year investment horizon. So we're not going to hand out the $100 million all at once. But we do have dedicated folks in our Intel Capital group that are reviewing prospective investments. And the money has been marked for the purpose of alignment with our connected car vision. We know we're not going to build all this stuff ourselves. Even though we do a lot of software, more than most people think, we know it's going to take a lot more than that. And there's also very many hardware features that need to be complementing the Intel components in order to be successful in the connected car world. We also announced that we opened up a dedicated R&D facility in Karlsruhe, Germany. And the emphasis here is on D. This is the group, I'll say it generally, it's in the triple digits of employees that are heads down working on automotive solutions in software. So this is an indication of our investment and the results you'll see later on. We have one of the largest partner programs, second only to IBM's and Microsoft's partner program, 11,000 members of Intel's developer program. ISVs, independent software vendors, about 85% of them already use Intel software tools, so they're very familiar with them. It's a pretty good success rate. And kind of to top it off, if Intel were a software company, it would be the 6th largest in the world. Now, we don't call ourselves a software company, but a pretty large software company. About 10,000 employees at Intel do nothing but software. They don't build any hardware. They build software and they mostly give it away. It's either our tools or it's our development components that get contributed upstream in the open source community, or it's board support features that enable the use of Intel silicon in a system. We are the #1 contributor to the Linux kernel now. We recently moved ahead of both Red Hat and IBM, who were holding that position for the longest time. Our maintainers are on the payroll that sit in important, significant places in that Linux community. So we have an influence over what the standards are going to be. but not standards in a traditional standards body, but standards in terms of the software that's available, the code that actually is usable in the system. So kind of to wrap things up, I wanted to summarize where we're at. We're definitely looking for people to join us. As I mentioned, Intel is not going to be able to accomplish this task of establishing the connected car. Even getting that far down the road is going to take a huge collaborative effort. It's much more than just the minor innovations that you see today that are getting headlines. When you watch a car commercial on TV, it almost always focuses on the head unit, the fancy display, even some of the integration of phones. These are minor innovations compared to what we need to do and what's the opportunity. So if you're an innovator and you're interested in enriching the car experience and letting the car take care of itself, and allow you, the driver, or your customers, to focus on the pleasures of driving, and you're that type of innovator, then we're interested in investing with you. And it's a two-way street, so I welcome your comments and input as we go throughout the day on working with Intel. Thank you very much.